All right, just want to make a quick little video, 8.2b, simplifying radicals, because I think this is holding us back a little bit when we're working with these special right triangles. So I thought I could kind of maybe give you a couple examples. I'm just going to go through and do a little bit of a few problems here and there to kind of get you started. So it says simplify the radicals, and then for this assignment, please rationalize the denominator, meaning we're not going to allow radicals to be in the bottom. So when we get to the division problems, that's probably going to come up. So let's just start with number one. So I have 3 radical 6 times radical 12. Couple different ways you could do it. You could start simplifying the radicals individually right now, which I would maybe be tempted to do if the numbers were getting too large. For instance, this is not one of these problems, but if I had like the square root of 18 times the square root of 14, instead of timesing them together and getting some big old number, I might decide to break these up into like the square root of 3 times the square root of 9 times the square root of 2 times the square root of 7 or something. Maybe I would want to do that because I see I could get kind of a perfect square out of there and not deal with, a really large number. But I think most of these are going to be pretty small. So I'm going to just multiply them together. So the 3 is on the outside. He's the only number on the outside. Well, then the square root of 6 times the square root of 12 is the square root of 72. So we can break that down, and you could either do it the perfect square way or you could do it the factoring way. I don't know. This one maybe I'll just do the factoring way. So 72 can be, 2 and 36 kind of came to mind. 9 times 4 comes to mind. It's really, I don't want to circle that because that's not done. Really, whatever 2 numbers come to your head first. 9 can be 3 times 3. 4 can be 2 times 2. And then the deal is, since we're dealing with square roots here, we pair them up into 2s. So when you have a pair, you're going to count that once. All right? You're going to count that once. And then another pair, we're going to count that once. And then we have a loner that we're going to put inside of the radical. So your loners always go inside the radical. Your pairs go on the outside. Now I can't forget the original 3. I had a beginning 3 out there too. So, this part came from here, and then the original 3. So now when I clean it all up, 3 times 3 is 9 times 2. This comes out to be 18 radical 2. Now you'll know if you did it right by checking your decimals. So like if you want to, I could punch that in the calculator, and I could say 18 times the square root of 2, and I get 25.4-ish. And then you could go up here to the top, and you could multiply that out. 3 times the square root of 6, parentheses, times the square root of 12, parentheses, and I get the same number, 25.4. So I know that I did it right. So you always should be able to check yourself on these. So number 2, one option would be to just multiply it out. And we're going to say, okay, that's a square root of 200. This one I'm going to do a different way. I know the perfect squares, 4, 9, 16, 25, blah, blah, blah. And I know 100 is on the list. So I know I could actually break this up into the square root of 100 times the square root of 2, which is really helpful because I know what the square root of 100 is. It's just 10. And I can wrap that one up kind of quick. So that's kind of one way to go about it. Let me skip down, just see if there's anything else that looks interesting that might be a little bit different. I don't know, maybe I'll do number 7. Number 7 looks a little bit trickier maybe. Except for the square root of 25, that's pretty easy. That's just 4. Oh my God, this one's super easy. Probably shouldn't even have done this one. And that's just 4, and that's just 2. So that comes out to be just 40. So sometimes it looks like there's some perfect squares kind of built into here. I see a perfect square there. So most of these look pretty straightforward. Maybe number 10, I'll kind of show you the split up method. So if I don't really want to multiply, like one option would be to call this the square root of, 120? And I could start working from there. But another option, if I don't like big numbers, I could just start busting this up right away and say, well, how about we go the square root of 4 times square root of 2 times the square root of 5 times the square root of 3, and just kind of go that route. And this is 2. Nobody else really has any perfect squares, so maybe we just group them all together. 2 times 5 times 3, and that is 30. And I'll just call it 2 radical 30. I'll double check myself just to make sure we get the same answer. 2 radical 30 is about 10.95, and the square root of 18 parenthesis times square root of 15. Why did I say 18? Square root of 8 times the square root of 15. Boom, same number. 10.95, blah, 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 blah. So you could break it up individually, or you could multiply it together and then break it up. Totally up to you. Division problems. So let's kind of tackle some of these guys. Well, right away, I'm not allowed to have that square root of 20 in the denominator, but I could do a couple things. You know, there's so many options. There's a lot of flexibility for you to be kind of creative. But I want to break that square root of 20 up into the square root of 4 times the square root of 5. I'm just going to go that route this time. And I did that because now I have a square root of 4 and a square root of 5 on top and bottom, so they can cancel. So they're gone. Now I need to hold a 1 for a place value up there. Now a lot of teachers would be say, hey, that's cool, 1 over radical 5, you're good to go. But since I asked you to rationalize the denominator, we need to take this and we need to multiply it by radical 5 over radical 5. So when I do that, when I multiply the top, I just get the square root of 5. And on the bottom, square root of 5 times square root of 5 is just 5. So you could do it that way. Maybe I'll try number 12 here. Number 12 is, well, that's 5 times, the square root of 9 is just 3. So I have 5 times 3 on top. Notice I left the 3 because I kind of seen this 3 on the bottom that I might want to cancel out with here in a minute. 3 and then radical 15. I could break it up, but I don't really see the advantage because when I break it up, I have a radical 3 and a radical 5. And I'm like, there's really no help there. So maybe I'll just leave it. Radical 15. Again, 5 people might do this 5 different ways. As long as we all get to the same spot, we're good to go. I'm going to cancel those 3's out. So now I have 5 over the square root of 15. And let's rationalize it. Multiply it by it over itself. And on the top, I just get 5 radical 15. On the bottom, square root of 15 times square root of 15 is 15. And now I can kind of reduce this fraction. 5 over 15 is 1/3. And I think we're about to be done. Square root of 15 over 3. And I know I'm done because that square root of 15 on the top, there's really nothing to do with it besides break it up into 2 radicals, but neither of those they don't allow me to get to a whole number. So there's really no point of going any further. Maybe I'll do one more. I don't know. 18 looks interesting. Let's just jump on 18. So, and this is kind of all about strategy. You could, maybe I'll show you 2 different ways just to show you some flexibility. So the first way, I think either way I'm going to go, I see a 4 over 2. So before I even get started, I'm going to reduce that to 2 over 1. All right. So now I have 2 radical 3 over, I don't really need to put 1, radical 6. And I could just right now go after rationalizing the bottom if I wanted to. I could just say, all right, let's rationalize the bottom. And I'm going to get 2 radical 18 over 6. Still got a little bit of work to do here. 2/6 is just 1/3. So I did that part. So now I have the square root of 18 over 3. But the square root of 18 can be broken down because that is the square root of 9 times the square root of 2 all over 3. And then the square root of 9 is just 3. And then I got 3 on top and 3 on bottom. So man, at the end of the day, all I'm left with is a little old radical 2. So that was just one route to go. Another route to go would be, well, if I have 2 radical 3 on top and radical 6 on the bottom, maybe what I want to do is maybe instead of leaving radical 6 on the bottom, I want to break it up into 2 times 3. Because I can wipe out a radical right there. So now we just have 2 over radical 2. And now we rationalize that. And I get radical 2 over radical 2, which is just 2 radical 2 over 2. But then again, these cancel. And I'm left with just the square root of 2. So either way, man, there's a lot of different ways. I don't care how you do it, but should all get to the same point. So pick your method, find out what you like. You might change your mind depending on the problem. I know I do, or I get bored and I just want to keep it interesting. All right, hopefully this helps you. See you.